In Math Lesson 3.8, we're going to be working on renaming fractions and mixed numbers. Make sure you have that whiteboard with you along with your math journal and a pencil. So we're going to look at fractions and decide if they are greater than 1 for our warm-up. So on your whiteboard, would you please number 1, 2, and 3. 1, 2, and 3. I want you to look at the fraction and tell if it is greater than 1, and then which two whole numbers is this fraction between. So I'll do the first one for you. Think of it as this. Think of fraction as division. How many 2's are there in 3? Well, there's 1, right, with some sort of remainder. So it's 1 plus a remainder, so it's 1.5. So this is between 1 and 2. I want you to do 2/5. Is it greater than 1? And what two whole numbers is it between? And then 7/3. What two numbers is it between? So number 1, 3/2 was the same as 1.5, which it would be between the whole number 1 and 2. So what two whole numbers is 5/2 in between? And what two whole numbers is 7/3 between? Go ahead and stop the video or pause it at this time. All right, number 2, 5/2. Well, I don't even have to figure out my remainder, but I know it's greater than 2, so it's between 2 and 3. How many 3's are there in 7? Well, there's 2 with a remainder, so it has to be between 2 and 3. All right, go ahead and wipe off your whiteboard and number 1 to 3 again. Remember, think of fractions as division. Again, each of these fractions are called improper fractions, which means the numerator, the number on top, is greater than the denominator, the number on the bottom. So what I want you to do is tell me what two whole numbers, is this fraction between. So for example, number 1, how many 2's are there in 11? There's 5 with some remainder, so it would be greater than 5 but less than 6, between 5 and 6. Go ahead and pause your video and complete number 2 and 3. How many 3's are there in 17? Well, there's 5 with the remainder, so it's between 5 and 6. How many 4's are there in 26? This is why you need to know those multiplication facts very quickly, be able to recall them. Goes in there 6 times with the remainder, so it's between 6 and 7. Again, using your whiteboard, it says write 21/5 as a mixed number. A mixed number is a whole number and a fraction. So for the number 2 and 1/3, that would be a mixed number. It's a whole number plus a fraction. Explain to a partner, well, what you're going to do is explain to your whiteboard, show me on your whiteboard, how you know that your mixed number is another name for 21/5. You can use fractions, circles, a number line, or drawings to help you. So the first thing I want you to do is to think of 21/5 as 21 divided by 5. So on your whiteboard, would you go ahead, put 21 in the dividend, and write 5 as the divisor. How many 5's are there in 21? Well, it goes in there 4 times, right? 5 times 4 is 20. Go ahead and subtract that. The remainder, when we write that as a fraction, goes on the top. So go ahead on your whiteboard, write that as the numerator. The denominator is the divisor, 5. Now, what we're going to do is I'm going to go ahead and show it to you on a number line to see what that would look like. On this number line, you can see between 0 and 1, there are 5 equal segments. 1, 2, 3, 4, 5. So my denominator is fifths. And if you were to go along this number line and just continue to add one number to the numerator, fifths does not change. Each segment between the whole numbers is divided into 5 equal sections. Let me show you this next one. 1, 2, 3, 4, 5. It still stays fifths. So if I look 4 and 1/5, remember is the same thing as 21 fifths. So here would be my 21 fifths, which would be the same as 4 and 1/5. Is 1 and 16 fifths another name for 21 fifths? Why or why not? I'm going to go ahead and add a picture. I'm going to go ahead and these are all divided into fifths. So I'm going to keep my denominator the same, right? So let's see if there are 21. And remember, they're all divided into fifths. So I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 fifths. That's where that comes from. Each one is divided into fifths. Would that be the same as 1 and 16 fifths? Well, here's one whole. Now let's see if I have 16 left. Go ahead and erase this for now. All right, here's one whole. Let's count and see if I have 16 left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 fifths. So 1 and 16 fifths would be the same as 21 fifths, which would also be the same as 4 and 1/5. Here we go. 1, 2, 3, 4 full circles and 1/5 more. Those are all equivalent fractions. Let's go ahead and move on to journal page 90. Journal page 90, renaming fractions and mixed numbers. Solve by following the steps. You can use fraction circles, number lines, or drawings to help you. So let's go ahead and draw 2 circles and then 3/4. I'm going to go ahead and divide this, and I am going to erase part of it, so be aware. I only want 3/4 of it. So 1/4, remember the denominator always tells me how many equal sections. So that is what 2/4, 2 and 3/4 would look like. So we did this, check. Break apart one whole into 4/4. So go ahead and do that with one of the circles. What's another way to say that now? Well, we have one whole circle plus, let's go ahead and keep adding this. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, and 7/4. So another way to show 2 and 3/4 would be 1 and 7/4. Number 2 says find another name for 14 thirds. Show 14 thirds. Make as many groups of 3/3 as you can. Trade each 3/3 for a whole. So I need 14 of them. So if we draw kind of like that, this would be 1, 2, 3. That would be 6, 7, 8, 9, 10, 11, 12, 13, 14. So here's 1/3. Each of those are a third. So I'm going to get rid of this last one. That should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 thirds. So go ahead and draw 14 thirds. If you need additional time, remember that's the beauty of pausing a video. So we did this. We showed 14 thirds. Thirds tells me that each one needs to be divided into 3 equal parts. Make as many groups of 3 thirds as you can, which we did. Trade each 3 thirds for 1 whole. So I'm just going to go ahead and shade those in. This is 1 whole, 1, 2 whole circles, 3 whole circles, 4 whole circles. So I have 4 and 1/3 and 2/3. So all together that equals 4 and 2/3. Remember, when the top number and the bottom number are the same, it equals 1 whole. Let's continue down the page. Write another name for each mixed number that has the same denominator. Check that your trades are fair and record them. So in number 1, this example, 3 and 8/6, they traded 1 whole for 6/6. Remember, the denominator needs to stay the same. They added 6 onto the numerator, but remember, 6 never changes. Just as in this previous one, the thirds, even though we traded, it still was divided into 3 equal parts. So let's start with number 3. The name is, we're taking 2 and 4/5. I'm actually going to do the trading first. I'm going to trade 1 whole. What is my denominator? 5ths. So in order to trade 1 whole for 5/5. So if I take 1 whole from 2, now we only have 1 left. I'm going to add this 5/5 to my numerator. Remember, the 5ths does not change, but I add 5 plus 4 is 9. 5th stays the same. It's still divided into 5 equal parts. So 1 and 9/5 would be the same as 2 and 4/5. Number 4, I am going to trade 1 whole, just like I did here. Remember, 3 thirds was the same as 1 whole circle. So I'm going to trade 1 whole for, my denominator stays the same, for 10/10. So if I borrowed or traded 1 whole, that would turn to 0. So I took 1 whole and made it 10/10. I'm going to add the 10 to the 12 to get 22, but my circles are still divided into 10 equal parts. Number 5, fill in the missing whole number or missing numerator. So I am going to take 4 thirds and I'm going to trade 3 thirds of it for 1 whole. So they added 1 whole to the 1. You take 4, and remember I already traded, so I took 3 away. I'm left with 1. Let's look at number 6. I'm going to trade 1 whole. Remember, my denominator stays 5ths. 5/5. So they took 5/5 from this to get 2/5. So this would have been 3. And number 7. here, I'm going to trade 1 whole for 2 halves. Remember, the denominator doesn't change. It's still going to stay 2. I'm going to do that again. So if I'm going to go for 2 whole, it would be twice as much. So I'm going to take 4 away from that. 4 halves. Remember, we only subtract the numerator. So I'm left with 5 halves. 4 and 5 halves would be the same as 2 and 9 halves. Mojo the monkey has 2 whole bananas and 5 half bananas. Write a mixed number to show how many bananas Mojo has. Well, he has 2 and 5 half bananas. Manny the monkey has 4 whole bananas and 1 half banana. Do Mojo and Manny have the same amount of banana? Explain how you know. Well, if Mojo took 4 half bananas, so if he took away 4 of those half bananas, that would equal the same thing as 2 whole bananas. So if we added 2 whole bananas onto that, because he took those 4 halves to put them together to make 2 wholes, he would end up having 4 and a half. Look at what Manny has. So Mojo traded 4 half bananas for 2 whole bananas, which equaled 4 and a half. Marcus, the monkey, had the same amount of banana as Mojo, which was, remember, 2 whole bananas, 5 half. He only has half bananas. How many half bananas does he have? Well, 2 whole bananas, if he were going to break them in half, would be 4 halves, right? Plus 5 half bananas. They're still half bananas. They're not in ninths. They're not in fourths. They're still halves. He would have 9 half bananas. So Marcus has 9 half bananas. And we know, watch, how many 2's go into 9? 4 of them with a half left. So that would equal 4 and a half. Let's move on to journal page 91. Journal page 91. It says connecting fractions and division. Write a division expression to model each story, then solve. You can use fraction circles or pictures to help, or draw pictures to help. Olivia is running a 3-mile relay with 3 friends. If 4 of them each run the same distance, how many miles will each person run? Well, we're going to take 3 miles and divide it by 4. They will each run 3/4 of a mile. Chris has 3 pints of blueberries for fruit salad. If he splits the blueberries equally into 8 serving bowls, how many pints of blueberries will be in each bowl? We're going to take 3 pints divided by 8 serving bowls. They would have 3/8 of a pint. Let's do one more problem. 4 students share 9 packages of pencils equally. How many packages of pencils did each student get? We know our answer will be more than 1 because there's 4 students and 9 packages. So I would take 9 packages, divide them among 4 students. Okay? We could say that they each would get 9/4. Remember, how many 4s are there in 9? Well, there's 2. 4 times 2 is 8. They each would get, another way to say that would be 2 1/4 packages.